Welcome to the fascinating world of non-optical astronomy, where we explore the invisible universe beyond the reach of traditional telescopes. This journey will uncover the mysteries hidden from our eyes. Optical telescopes are limited to observing visible light, leaving many cosmic phenomena hidden from view. The visible universe is just a small part of reality, and much remains to be discovered beyond it. Looking beyond visible light reveals objects that are too cold, hidden by dust, or extremely energetic. Different phenomena require different wavelengths to be understood, expanding our cosmic perspective. Visible light is only a tiny portion of the electromagnetic spectrum. By exploring other wavelengths like radio, infrared, UV, and gamma rays, we can uncover the universe's hidden secrets. Non-optical astronomy studies the universe using non-visible radiation, complementing optical astronomy and proving essential for modern space science. It opens new windows to the cosmos. Earth's atmosphere blocks many wavelengths, allowing only some radiation to reach the ground. This limitation links to previous lectures on atmospheric effects on astronomical observations. Radio astronomy observes long-wavelength radiation, revealing galaxies, pulsars, and cosmic backgrounds. Mostly ground-based, radio waves pass through the atmosphere, uncovering hidden celestial structures. Radio waves reveal the structure of galaxies, pulsars, and early universe signals. They uncover hidden celestial structures and events, providing insights into the universe's formation and evolution. Infrared astronomy observes heat radiation, useful for studying star formation and dust-covered regions. However, the atmosphere absorbs much infrared radiation, posing challenges for ground-based observations. X-ray astronomy observes high-energy X-ray radiation, studying black holes, supernovas, and galaxy clusters. Space-based telescopes are required, providing a unique view of extreme cosmic environments. Gamma-ray astronomy observes high-energy gamma radiation, probing exotic events and extreme objects. Space-based telescopes reveal the universe's most extreme phenomena, like gamma-ray bursts and black holes. Ground-based observations are easier to build and maintain but limited by Earth's atmosphere. Space-based observations are necessary for X-rays, gamma rays, and most infrared, offering clearer views of the cosmos. Each type of astronomy reveals unique information about the same object. Optical, radio, infrared, and X-ray views provide different insights, enriching our understanding of celestial phenomena. Multi-wavelength astronomy combines data from different wavelengths, providing a comprehensive understanding of the universe. It reveals greater detail, allowing exploration across the full electromagnetic spectrum. Non-optical astronomy sees invisible radiation, penetrates through dust, and explores extreme phenomena like gamma-ray bursts and black holes. It expands our understanding of the universe's complexities. Different wavelengths reveal unique aspects of the universe. Non-optical astronomy sees unseen, extreme phenomena, and multi-wavelength astronomy combines all views for deeper understanding. Stay tuned as we dive deeper into the physics of light.